All right, so we've made it all the way to module 10. In this module, we're going to talk all about what it takes to diagnose a vehicle. So we're going to talk about diagnostic procedure. We're going to go over what to do on test drives. I'm going to give you guys the secret weapon to success here. We're going to go over scanning for codes, diagnosing common issues. We're going to go over the different strategies there. And then I'm going to give you guys a couple of example diagnoses. So here we go. First thing, I just want to remind you guys the picture on the left and the picture on the right. So what separates a mechanic from a technician is pretty much the ability to be able to troubleshoot problems. And remember guys, a mechanic is a part swapper and a technician is a problem solver. So which one do you want to be? And you can also imagine which one makes the most money. So let's get started here. So what is a diagnosis? A diagnosis determines the required action needed to repair the vehicle. A diagnosis will usually include a quick inspection of the vehicle. Just want to let you guys know that diagnosing vehicles is not necessarily easy. It is one of the more difficult jobs you will encounter. It takes time to get really good at them, but the only way to get good at them is with experience. So I'm going to give you guys the best tools for your arsenal to be able to get it right the first time and accomplish your goal of diagnosing the vehicle. So when you get good at this, you should be able to diagnose any vehicle issue in 45 minutes to an hour or less. I said 45 minutes is probably the standard for some, unless it's something comes in for something quite obvious. But remember this, sometimes your diagnosis can result in needing to clear more time with the customer. So guys, different shops are going to do it differently, right? Every shop's going to have a little bit different process of doing things. What I do with my shop is we offer a $45 diagnosis. And we tell people up front, your diagnosis is $45 unless we do any repairs to the vehicle, then the $45 goes right towards the repair. And what that weeds out or prevents is people just fishing around trying to get a free diagnosis of their vehicle and then fixing it themselves. And guess what? I learned that by experience. I used to offer free diagnoses and I don't anymore. So anyway, so where I'm going with that is sometimes a good example is an electrical issue. We give the customer their $45 or free diagnosis. Say you spend an hour with it. You spend an hour with it, you at least know what direction to go in now. But sometimes you could say, all right, we're gonna have to clear another couple hours to really get this thing nailed down. So at that point, you call the customer and ask for more time because with electrical repairs, 99% of the time is spent diagnosing it, or 90% of the time is spent diagnosing it, 10% of the time is actually spent repairing it. But follow my procedure on every diagnosis. I just want to really nail that down. Make sure to follow this procedure on every diagnosis because it is very, very easy to get sidetracked. Next thing you know, you're 3 hours into a diagnosis and you still are at square one. So follow this procedure so you don't get sidetracked and get going down a path that you're not getting paid for. That's really the ultimate thing. We got to make sure we do this strategically so that we're not wasting our time. Okay, so let's talk about the diagnostic procedure. We're going to go through the step-by-step way to do this here. So step number one, you're going to grab your diagnosis sheet and write down the list of complaints. And I'm going to be talking about two sheets, a diagnosis sheet and an inspection sheet. And I'll show you those in a minute. I'll also have links to them at the bottom of this video. So grab your sheet, write down the list of complaints. Step number two, test drive the vehicle and attempt to duplicate the complaint. See with me so far? Step number three, we're going to scan for codes and write those codes down, document those codes if applicable. And what I mean with that is unless the vehicle came in for a brake squeak or a noise complaint. So when applicable, scan for codes, document the codes, and then watch data. Watch data related to the codes that you pulled. Step number 4, clear those codes, continue to test drive or test drive the vehicle again to see if codes have returned. Also, see if clearing the codes changes how the vehicle performs. Okay, so you read your codes, so you drive the vehicle, you might feel something funny going on, you drive the vehicle, you get your codes. I always stop, clear the codes, go drive the vehicle again, or I stop halfway between my test drive where I'm about to turn around, pull the codes, clear the codes, drive it back to the shop. Well, I want to see if those codes come back while I'm test driving it. I also want to see if the vehicle acts any differently with those codes cleared. Step number 5, research codes and complaints. Wherever your shop information system, so research the codes you pulled. Step number 6, give a visual inspection of the possible problem. Remember, be a detective. We always have to be a detective in this job, don't we? And we always have to think, why did this fail? So if you find a failure, always be a detective and think, okay, why did this fail? Step number 7, now you're going to give the vehicle the quick inspection that we talked about. You're going to do the quick inspection to see if there's anything else the vehicle needs. Step number 8, you're going to, again, different shops might do this differently, but what I recommend is you, the technician, come up with a suggested labor time plus parts cost. The reason I like the technicians to do it is because you could look at the job, your eyes are on the vehicle, right? And you're going to say, book time is this, however, we got some serious rust here, it's going to take me twice as long to do the job. So book time's 3 hours, I'm going to quote it at 5 hours because I know we're going to run into some problems here. So that's why I like the technicians to actually come up with the suggested labor time. So final step number 9, advise the service writer of the necessary repairs. So get with the service writer and go over everything you found and what the vehicle needs to be repaired. I got the example here of, here's your diagnosis sheet, and you can see we have a spot right here for, there we go, for the vehicle complaints. I have a little spot here to write down anything you notice on the test drive, you know, whether that be a noise, misfire, anything like that. DTCs, here's where you're going to write the codes you pull out of it. Possible causes. So this is where I like to make little notes of when you look at your shop's information system, and it says, you know, you have this and this problem, inspect this area, this area, this area. So possible causes, you're going to write yourself a couple notes here. I'm going to check this ground wire. I'm going to check, you know, whatever it may be. I'm going to check for intake leaks, or I'm going to check my mass airflow sensor, whatever it may be. Visual inspection of problem areas. Just write down if you find anything, like if you have a vibration or noise, you could put on there, you know, found wheel bearing to be extremely loose, found brake pads to be metal on metal. So just a little heads up here so everybody's on the same page. Write down what you see. Okay, so then we go to this side, recommended repairs. Here we go, recommended repair number 1. We're going to put on there brake job, parts, brake pads, brake rotors, suggested labor, 1 hour. Go ahead and give that to your service writer. That's it. Okay, so here is our quick inspection sheet, and we talked about this earlier in module 2, I believe, module 1 or module 2, and this is the sheet I use. So I go through it and see if any of this, you know, inspect everything in the vehicle, see if we need to address any of those items. Okay, so let's talk about the test drive. The test drive is a very important part of the diagnosis procedure. So remember, guys, this is not a joyride. We're not cruising here. Turn off the radio and pay attention. You know, you have to. You're getting paid to do a job. So what we do, drive the vehicle for at least a few miles, more if necessary, to try to listen and duplicate the complaint. Okay, you're going to do 3 things while you drive. You're going to listen, you're going to feel, and you're going to document. So let's talk about that. You're going to listen as you drive this vehicle. You're going to listen for wheel bearings, and just about every vehicle, every vehicle that I test drive, I always do this. I listen for, I know wheel bearings going to sound like a low, deep kind of a hum. And if you go ahead and sway the vehicle side to side and that noise changes, you know you have a wheel bearing making noise. Okay, you're going to listen for brake squeals, grinding, and then listen for anything else out of the ordinary. Clunks, creaks, squeaks, bangs, pop, you name it. Listen for odd noises, write them down. Okay, what are you going to feel for? So drive the vehicle, you're going to feel for any driveline vibrations, any suspension clunks or odd feelings. You're going to check the engine runability, make sure you have full power, make sure you don't feel, check and see if you have full power, document if you feel any misfires, etc. You're going to feel for brake pulsations, you're going to feel for transmission operation, etc. So just be alert, pay attention to everything, and document if you feel anything out of the ordinary. And then finally, guys, watch the gauges. So something that's easy to overlook, all of a sudden you notice halfway through your test drive, holy cow, my temperature gauge is getting warm. I'm starting to overheat. But also, watch all the gauges, or you'll watch that, I had a quarter tank when I left, now my fuel gauge is pegged at empty. Maybe you have like a fuel sender going out, something like that. So just examples here, but also pay attention to how long the engine takes to warm up, because a lot of times, especially in cold weather, we get a vehicle in for something else, we drive it, and we realize this vehicle's taken way too long to warm up. I drove this thing for 10 minutes and I still don't have good heat. So then a lot of times we'll say, by the way, your thermostat's starting to get weak. If you want good heat, if you want your engine to warm up faster, get good heat out of it, you should replace that thermostat. Okay, are you guys ready for this? I'm going to give you our secret weapon right here. So this is our secret. The customers do not need to know about this. However, this program that I'm going to talk about here can basically turn you into an instant genius. And it's just awesome. It gathers technicians across the country and it basically funnels their knowledge into one website. It is called Identifix. You've heard me talk about it, but guys, this is awesome. I use this for nearly every diagnosis I do. So what is Identifix? Basically what this is a vehicle information system. So it gives us all the vehicle information we need, torque specs, wire schematics, you name it, all these different things, repair procedures, but that's not what makes it special. What it also does is it gives other technicians the ability to post comments and record their repairs. So it gives us access to what other technicians have found and repaired for certain problems. This thing is incredibly helpful, and it is such a time saver for us. It is well worth the money. I think right now our shop is paying about $150 a month for it. We take advantage of that. I mean, we make that back in a day, I would say. So, I mean, there are other systems out there. There's Mitchell. ShopKey is another really popular one, because every shop you work at is going to have some sort of, vehicle information system. And, but anyways, this is the one I use in my shop, and this is the one and this one is my favorite. So again, guys, you can type in whatever vehicle, you enter your vehicle into the system, then you type in your symptom. Whether that is, I have a lien code, and it's going to pop up, oh, there is 65 confirmed fixes for technicians replacing the PCV valve on this vehicle, or the valve cover, or there's a intake boot that's common to crack, guys, and it points you right towards the problem. Even if it's not the problem, it points you right towards an area to look at. So this is such a good help. And I'm going to have a demo in this. So I'm going to have an Identifix demo in the bonuses section that you can watch and check it out. Okay, well, we're moving on. So we're moving on to scanning for codes and watching data. So we're talking about hooking up the scanner. We're going to hook the scanner up to the DLC, the data link connector. Okay, that's on every vehicle. Right there, oops. Right there we are. So that's going to be on every vehicle, 96 and newer. So 96 and down, each manufacturer had a different connector, which was really stupid. Your scanner had about 50 different connectors. You had to go through and find which one goes where. But 96 and up, all the vehicles have this same exact connector. You plug in your scanner, boom, you're hooked up to the vehicle. This is your gateway to the vehicle's brain. Okay, so let's talk about scanning for codes and watching data. So unless the vehicle's complaint is a noise or vibration or something that's obviously we don't need to hook the scanner up to it, always hook up the scanner for your test drive. I mean, unless it's obvious, guys, like a headlight or something like that, always hook up the scanner, because sometimes you'll pull codes out of something related and you would never guess that there'd even be codes for that issue. So, okay, scanners. As we go over scanners, they are going to use a lot of abbreviations. You will get used to this, but to help you guys out, I made an attached PDF file, a complete list of all the abbreviations used. I know, I'm a nice guy, but example, like you're going to see on the scanner, ECT, a data PID for ECT. What's that? I don't know. Well, that stands for engine coolant temp. So I got a list, puts all the common ones on there for you guys. Make sure you carry that with you, put that in your toolbox somewhere. Okay, so when we're scanning for codes, a couple ways we can do this. You can scan individual modules. You can go into the module, select it, scan individual modules, or on some scanners, you can run a full DTC scan. It's going to check all the modules the vehicle has and pull codes out of them. Again, guys, I'm going to have a bonus module on scanner operation, but this is giving us just a brief idea. Okay, so when you hear us refer to watching data, that basically means we want to watch what the sensors are telling the computer. So it is sometimes helpful to manually look at these sensors. You can't rely on just codes alone. We want to see what these sensors are putting out, right? So we do that while watching data on the scanner. And here are some of the important ones that I like to watch during a diagnosis. So ECM data. So when I have a runnability concern come in, I always just quick pull up the data, and I like to scan these different data PIDs and just look to make sure they look okay. I like to watch O2 sensors. I like to watch the engine coolant temp. I like to watch the mass airflow sensor readings. I really like to look at the fuel trims. And I also like to watch for misfire counters. Okay, so we're going to hop over to diagnosing some of the common issues that you guys are going to run into on a common basis. So again, let's be detectives. Okay, so we're going to talk about diagnosing O2 sensors. A faulty O2 sensor can cause a ton of runnability issues. Usually they set codes, but sometimes they don't. So how do we test these suckers? Couple ways, couple little tricks I got for you. So one thing I like to do is this. If you pump the throttle quickly, you should see the O2 sensors go to full rich. Okay, so if you got an O2 sensor, you're watching the data on the scanner, you want to see if the O2 sensor responds like it should while the engine's running. Pump the throttle, on, off, on, off, on, off, all the way full throttle. Pedal it, if you will. You're going to see the O2 sensors, or at least they should, go to full rich. Another way you can do that to see if the O2 sensors are responding the way they should is you can actually add fuel using your shop's acetylene torch. The first time I heard about this, I was like, that sounds like a really bad idea. But I have actually done this quite a bit over the past few years. So how you do that is you're going to take your torch, you're going to slowly add acetylene, not oxygen. I don't know what would happen if you put oxygen to the engine, but it probably wouldn't be good. So acetylene is the fuel, the gas, the fuel. Oxygen is oxygen. So slowly add your acetylene and you're going to grab that, you're going to put that somewhere in the intake. So I like to pull like a vacuum line off, just plug it onto the tip of my torch. So slowly add acetylene. You're going to see the O2 sensors react. They're going to go full rich. And you're also going to notice your fuel trims react to this. So we're going to talk about fuel trims. Watch those fuel trims, guys. So fuel trims are the values showing us whether the ECM is adding or subtracting fuel to obtain the perfect mixture. Now they usually read on a scale between negative 20 to positive 20%. All right. Now a perfect engine will show about 0%. So guys, what we want to see on a perfectly running engine is 0%. If we see that there's a positive 10% on a fuel trim, that means something's going on, that the computer is adding more fuel than it normally wants to. It's adding some fuel. If we see negative 10%, it's taking away fuel to compensate for something. So it shows us that. Okay, you will see fuel trims labeled long-term and short-term, LT and ST. Also bank 1 and bank 2, just like O2 sensors. Unless it's a 4-cylinder or an inline 6, of course, then there's only one bank. Now, rule of thumb is that short-term values are directly related to what the upstream O2 sensors are reading, and that the long-term values are related to what the downstream sensors are seeing. But that's not set in stone. I've seen some different things that don't necessarily agree with that. But basically, so what's going on here is if you notice a higher than normal reading, so again, 0 is ideal, but 0 to 5% is our acceptable range. 0, I'm going to say negative 5 to positive 5 is what I should have said there, is our acceptable range. Okay. So if we notice a higher than normal reading, again, it's telling us the engine is adding fuel to compensate for something. Usually that's going to be a vacuum leak. Lower than normal reading, the engine is taking away fuel to compensate for something. So I just want to make sure this sinks in and makes sense to you guys. So basically what fuel trims do, they tell us if the computer is compensating for a problem, richening the mixture or leaning out the mixture to compensate for a problem. I remember when I first discovered fuel trims, when I started becoming a tech, it was like, wow, this is helpful. Okay, so we're going to talk about vacuum leaks and how to diagnose a vacuum leak. So if our fuel trims indicate that the engine is adding fuel, the first thing we want to do is check for a vacuum leak. Step number 1, listen. Pop the hood and listen. If you have a vacuum leak, guys, it's going to make a hissing sound. It's going to sound like a snake hissing at you. If you ever want to play around with that, go ahead and pull a vacuum line while the engine's running and listen to that sound. Step number 2, this is a really cool trick. Take some brake clean, spray the area and spray the intake area with the brake clean. So go ahead and grab a can of brake clean. You got your head under the engine, it's running. Now spray around the intake manifold with the brake clean and listen for engine RPM to change. Also, it's helpful if you have the scanner in front of you watching fuel trims. All of a sudden you'll kind of move to a corner of the intake, say, and the engine RPM starts to stumble a little bit or raises up or goes down. You look at fuel trims and wow, they react to that. You just found a vacuum leak. A third way to do it, if you still can't find a vacuum leak and you think there is one, grab a smoke machine. Fill up the intake full of smoke and look for leaks. So misfires. So what is a misfire? A misfire is a lack of ignition or a poor ignition of a cylinder. While you're driving it, it's going to feel like a thump in the engine. Now, misfires can be felt mostly when the transmission applies TCC or torque converter clutch lockup, and that's because we don't have the torque converter basically dampening what the engine's doing. It's a direct lock. So if that engine's misfiring, it's going to be most present in TCC lockup. Now, some manufacturers allow us to watch for these misfires while the engine is running. On the scanner, it's going to have misfire counters. Other manufacturers will have a power balance function that basically is going to allow you to try to identify weak cylinders. So some manufacturers that don't have either of these have what's called a mode 6 function, and you can go in there and it's called a secondary indicator. You can go in there, find a mode 6 in your scanner, and you find the one that's for cylinder misfires, and you're going to have to look them up one cylinder at a time, and it gives you basically values that we're looking at, minimum and a maximum value. It's showing you misfires. I know that's confusing. We'll explain that better later in the scanner module. Okay, so if you have a misfire that's present at idle, and you're trying to identify which cylinder it is, you're having a hard time with that, one trick you can do is unplug spark plug wires or the coils, unplug the actual electrical connector at the coils individually. So each cylinder you can unplug it one at a time and then plug it back in. Now go to the next one, unplug it, plug it back in to feel for a change. So you should unplug a cylinder and the engine's going to start to stumble, run worse than it is. You plug it back in, it smooths out a bit. And if you get to one and the engine doesn't change at all how it runs, you might have you just found the cylinder that's probably got the misfire. Okay, check out these spark plugs. So tech tip, when diagnosing a misfire, first make sure that the tune-up is up to date. Best way to do that is to pull a spark plug and inspect. Because guys, if we are trying to diagnose a misfire or a runnability concern and we do not have a tune-up that's up to date, we could be running around chasing our tail the whole time. So that's the first thing we want to check. Does it have good plugs in it, basically? Remember, a tune-up should be performed every 100,000 miles. Now, I wanted to show you guys these spark plugs. So you can see the difference here and what's happening. So a spark has a tendency to like to go from a sharp edge to a sharp edge. So on a new spark plug, you can see the sharp edge, it's going to jump right there. This spark plug over here, see how that's all eroded away? It doesn't have a sharp edge to go to, so it can have a tendency to just not fire at all, or a tendency to jump, off to the threaded area here. All kinds of different problems. So we want to make sure we have good spark plugs. Okay, another tech tip for you. Coil on-plug ignition coils are actually really common to fail. So if you're suspecting a faulty coil, guys, it's best just to replace both the coil and the spark plug, because sometimes we have ignition coil fail, but it also can foul out that spark plug. So I like to just replace them both. Whenever I replace a coil, I replace a spark plug, so you don't have to worry about it. Another tech tip for you. So the Ford 3.0 liter, also used by Mazda. So you'll see these engines in Ford Escapes, Mazda Tribute, etc., a lot of different vehicles. These things are famous for this. The coils can fail, but it also can damage the ECM. So as a preventative measure, we always replace the rear 3 coils when we're doing a tune-up, since they're behind the intake. So every time you get one of these engines, you pull the upper intake off. Kind of stinks. You got to pull the intake off just to get to the rear cylinders, but that's fairly common on V6 transversely mounted engines. So no matter what, when I get one of these engines in for a tune-up, we pull the intake manifold off. I always tell the customers, you really need to be replacing these coils now because they fail, and sometimes when they do, they ruin the PCM. So word of wisdom there. Another tech tip for you. If you find a cylinder is a dead hole, and what we mean by that is the cylinder is not firing whatsoever, it's a completely dead cylinder. Before you suspect anything else, I always suspect a possible fuel injector failure for a dead hole condition. Let's talk about fuel injectors. So now, fuel injectors are not that common to fail, but it does happen from time to time. There's a couple quick checks we can do. If you have a cylinder that's not firing, a dead hole, listen to the injector with a stethoscope compared to a good cylinder. A fuel injector that is properly firing will sound like tiny hammers tink, 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 being pounded on steel. If you have a failed injector, it's going to sound different than all the rest. It's just going to have kind of a dull thud, and you're just hearing some engine sounds there. You're not going to hear that tink, tink, tink of the fuel injector actually firing. Another test is to give the injector a tap test. And that's just what it sounds like. You take a screwdriver or something, and a small hammer, and you just tap on it lightly. Every so often you do that, and boom, it pops to life and your engine starts running good. If that's the case, you want to replace that injector. But also, you want to check pulse voltage to the injector. So we want to do that using right here at the connector, we want to just grab a test light. So we're going to unplug the connector, and we're going to put the test light into the vehicle harness side. Usually use a little paper clip, clamp your clamp to it, and stick your sharp end of your test light right there to the other side. With the engine running, it should dimly flash the test light. So I always like to check it against a known good cylinder. But there are also what's called Noid lights. It's actually a connector with a light bulb built into it, but a test light works just as good. Okay, let's talk about diagnosing a low power condition. So you drive a vehicle and it's just nutless, or it has no power. Typically, a low power condition is going to be caused by a weak fuel pump or a plugged catalytic converter. One of those two. So you can watch fuel pressure. Go ahead and hook up your fuel pressure gauge, watch fuel pressure while you're under a heavy load or wide open throttle. We want to make sure our fuel pressure stays where it is, because if it starts to drop down from a weak fuel pump, that could be causing our low power condition. Okay, so if you got a low power condition and you're suspecting a restricted exhaust system, possibly a plugged catalytic converter, the best thing I like to do, guys, is figure out a way to create an opening before the cat to relieve pressure. For example, removing an O2 sensor. So now there are other ways to do this. There's actually an exhaust backflow gauge that you can put in place of an O2 sensor and watch the pressure. So whenever I'm suspecting basically a plugged cat, I like to figure out a way to, whether it's separating the exhaust, pulling an O2 sensor, somehow giving the exhaust a way to relieve pressure before the cat. And of course, your exhaust is going to be really loud while you do that. What we're doing here, guys, is we're just looking to see if we do that and the vehicle makes power. So if we have full power. Now, I'm not, especially if you got an O2 sensor removed, completely unthreaded, removed, I'm not looking for the engine to run perfectly. I'm simply checking, does it have more power than before? So I get it on the road, I hammer that thing down. Before, say wide open throttle, I couldn't get it past 45 miles an hour before. Now, if I can, you just found a restricted exhaust, okay? So another tip for you is that a plugged cat, sometimes a plugged cat can smell like rotten eggs. It's going to have a really weird, and it really does smell like rotten eggs. So always use all your senses when diagnosing something, because low power condition and you have a rotten egg smell, good chance you have catalytic converter problems. Okay, so we're talking about diagnosing a no start. So when you get a vehicle towed in there, your service writer hands you the keys, so go check this thing out, it's no start. All right. So there's going to be two kinds of no starts we're going to talk about. A no crank condition or a crank no start condition. Okay, so the first one, a no crank condition, is just that you turn the key and nothing happens. The second one, a crank no start, we call it, is when you turn the key and your starter engages and your engine turns over, but it will not fire, it will not start. So let's start by talking about a no crank condition. And I know we went over this in the electrical, but we're just going to touch on it real briefly again. So for a no crank condition, grab your 12 volt test light. First thing, make sure your battery is fully charged. Now you're going to want to go ahead and check for constant battery voltage at one of the large terminals. So we're going to hop under the vehicle, locate the starter. You got two big terminals here and a little terminal here. On one of them, this one is going to be this one right here, you should have battery voltage. Doesn't matter if the key's in the ignition, laying on the seat, doesn't matter, you should have battery voltage. Next, you want to grab a helper, tell them to turn the key while you check for voltage at the small terminal. Finally, check for voltage at the other large terminal to see if it's transferring over. So what we have, battery voltage here. This right here is our small terminal or our trigger wire. So when your helper turns the key, we should be sending voltage here, which should in turn cause the solenoid to click. By the solenoid clicking, it should transfer power over to here. So basically, you grab your helper, have them turn the key. If you don't have voltage here, you got another electrical problem. It will not start if we don't send voltage there with it. If you do have voltage here, and you have voltage here, right away you know you have a bad starter or a bad starter solenoid. Sometimes we have voltage here, the solenoid clicks. We still don't have voltage here, bad starter solenoid. Sometimes we have voltage here, the solenoid clicks, and we do have voltage here, yet the starter still isn't turning. Now we've got a bad starter motor. Anyway, okay, so now let's talk about diagnosing a crank no start condition. So now back it up a minute. Let's remember before we start freaking out about this diagnosis, let's think about this. There's only three things this engine needs to run. Okay? Fuel, spark, and compression. So let's get down to the basics. So the first thing I'm going to do is I'm going to hook up my fuel pressure gauge and I'm going to check cranking fuel pressure. I'm going to see if this thing's making fuel pressure. Second thing I'm going to do is I'm going to grab a little inline spark tester. I'm going to see if this thing is sparking. If those both check out, now it's time to get a little bit involved. I'm going to check compression. Make sure we have compression on the cylinders. If a timing chain or belt has broken, usually you'll see an issue then with the engine compression. Tech tip for you. Basically, as a rule of thumb, engines should have more than 100 psi of compression to run. So there you go. Check with those three things. If it still doesn't start, it's deeper, but usually you're going to find it within those three things right there. Okay, here's one that you guys are going to like. Smoke signals. The vehicle's trying to tell us something. So if we notice that a vehicle comes into our shop and it has excessive smoke coming out of the tailpipe, let's pay attention to that and also pay attention to the color of the smoke. So there's three different colors that we're going to see: blue, white, or black. Okay? So if we notice a bluish colored smoke coming out of the tailpipe, that means we're burning engine oil. Okay, so that means there's an excessive amount of engine oil going into the exhaust and being burned. If we see white smoke, that tells us we have coolant getting into the exhaust. So we have an engine that's consuming coolant, most likely. Finally, black smoke. Black smoke equals fuel. So we have an engine that's running too rich, okay, allowing too much fuel into the exhaust. So there's just another way that we can be detectives looking for a problem. All right, so we're going to talk about noise and vibration diagnosis. Okay, so when diagnosing a noise, try to see if you can make the noise change by how you're driving it, because we're detectives. For example, if you are hearing a loud humming noise while driving, try a few different things. Try steering the vehicle left and then to the right. Try braking, try accelerating, try decelerating, see if you can get that noise to change. So a tech tip: if noise changes while steering to the left or to the right, what you are hearing is a wheel bearing noise. Now you always want to verify this using a stethoscope while it's up on the hoist. Or if you hear a high-pitched kind of a whine that can be changed by letting on and off the throttle, you are probably hearing noisy pinion bearings, which are in the rear differential. Okay, so now if you're feeling a vibration, see if you can change the vibration with the throttle pedal. Okay, so if the vibration is more noticeable when you're accelerating, the issue is most likely in the drivetrain. The drive shaft could be bent. We could have a loose U-joint. We could have a CV axle issue, etc. So when you notice a vibration that's more prominent when you're in the throttle or accelerating, that always indicates we have a driveline problem. If the vibration is only at certain speeds, usually this is a tire balance issue. Example, you drive the vehicle and you notice at 45 miles an hour, you get a little bit of a shimmy shake going on. You get up to about 60 miles an hour, it smooths out, it goes away. That's definitely an indication that you have a tire balance issue. Okay, so if you have a vibration, you always want to determine if the vibration is in the front or of the rear of the vehicle. So how we do that, let go of the steering wheel and see if it shakes. We use the same trick for diagnosing warped brake rotors. So you got a pulsation when you step on the brake. Go ahead and let go of the steering wheel, now step on the brake. If that pulsation's there and the steering wheel stays nice and steady, it's in the rear. If that steering wheel starts to shake left and right violently, we got our issue in the front. Tech tip for you. If you have a loud clunking sound while hitting bumps and you put it up in the air and everything feels tight, you're like, I can't find anything wrong. The ball joints are good, the tire ends are good. Suspect noisy struts. A lot of times struts can get worn out and noisy, but you go do your inspection, you don't find anything loose. Now we're going to say it's most likely coming from the strut. Okay, so let's talk about researching our problem, whether that is DTCs, which is diagnostic trouble codes, symptoms. We're going to talk about researching these problems. So we're going to do that using Identifix, which we talked about, Mitchell, Snap-on Shop Key. Guys, these are not cheat. This is not cheating. This is not cheating. It's a resource that we need to use, okay? We need to use as many resources as we can to get the job done. Okay, so these things are huge for helping our technicians today. We're going to want to look for common problems with your vehicle's complaint and start there. So whatever your complaint may be, research it, look for the most common complaint, start there. Right? That makes sense. And if it's not it, then you go to the next thing. But we want to start with the most common issue. And again, guys, let's research and learn how the system you are trying to diagnose operates. Okay, so if you don't understand how the system operates that you're trying to diagnose, you got to start there. You got to know how it works before we can know how to fix it, right? Okay, so guys, don't be scared. Hopefully you're not scared already. But here's the thing. Don't be scared to make a move. So instead of spending 2 hours diagnosing something and beating it to death, if you have a suspicion about a part that could be faulty or could be causing our complaint, just change it. All right? Here's an example. So I'm diagnosing a runnability problem. I think this O2 sensor is bad, but I can't say for sure. I think it's bad, but I'm not 100% positive. So you could either spend another hour hooking up meter leads and doing this and this and that and testing it, or just get another sensor and replace it. If you figure it out, the cost is probably about the same, isn't it? For your shop to pay you another hour to diagnose it, or just grabbing a sensor, popping it on. Now, I understand, guys, this might be tough to make your service writer understand or to persuade your service writer, but remember this, you, the technician, are in charge of the vehicle you are looking at, okay? I have a note on here, we are here to get things done, not beat around the bush all day. So, it's true though, isn't it? So, I get it, you don't want to start throwing parts at a vehicle, and especially, you don't want your service writer to get upset at you for doing that, but check this out. Your service writer or service manager will learn to appreciate your confidence even if you're wrong some of the time. I guarantee it, guys. So, you know, I am all about getting stuff done. So if one of my techs comes up to me and he goes, okay, so here's what I got going on. I think we need to start by replacing this sensor. I don't know if it's going to fix it, but we got to start there. Okay, do it. Or if he comes up to me, he's like, I got such and such an issue going on. I think it's this sensor here. Like, all right, do it. Sometimes we'll even replace it before talking to the customer, depending on how expensive it is. But a lot of times, you know, okay, your car came in for this. You guys, you know, sometimes it's like, well, the customer has to fix it, right? So if this does fix it, I'm not 100% sure, and I don't want to sound stupid. So I'm not going to call this customer and say, well, we think it's this. We'd like to try this first and see if it fixes it. Sometimes I take the gamble and just say, you know what, do it. And if it fixes it, I call the customer and be like, okay, we got it nailed down. Here's your problem. Boom. Here it is. Here's how much it costs to fix it. 95% of the time, you're going to say, yep, go ahead and fix it. 5% of the time, you're going to have a customer that says, well, I don't know, I might have to come back for that. I don't have $200 right now to fix it. And then you're screaming in your mind, you're like, then why the heck did you bring us your vehicle? All right, so every once in a while it comes to bite you, but most of the time, it's, you know, you're going to get the go ahead anyway. In my mind, it saves you a ton of time. On the other hand, sometimes we do it and it doesn't work. Then we keep going. So that way I didn't look like an idiot, right? I didn't call the customer back and say, so that didn't do it. So now we'd like to do this. I'm going to figure out a way to make that money back somehow, or maybe I'll just eat it. But either way, we got to get stuff done. So we got to start somewhere, right? Okay, so I got some example diagnoses for you guys. So example diagnosis, just like a vehicle's coming into my shop, I'm looking at the vehicle and I'm going to walk you through the whole process. Okay, so let's get going here. We got a 2007 Chevy Equinox that came in. Okay, our customer complaint, we have a loud humming noise while driving. Perfect. Okay, step one, we drive it. So we notice that the noise gets louder the faster we go. Noise seems to be coming from the front. Now the noise will also change when the vehicle is steered from left to right. Okay, you also notice that the steering wheel is shaking slightly while you're braking. Okay, so step number two, there's no codes. Through the code reader on, there's no codes. Step number three, get the vehicle up in the air, have somebody run it up. That means somebody actually drives the vehicle up on the hoist, gets it up to speed, and you use your stethoscope and you listen to the wheel bearings. You find that the passenger front wheel bearing is making the noise. Step number four, you give the vehicle a quick inspection and find that the front brake pads are only 20% remaining, and we had a pulsation with stopping, so we already know the brake rotors are slightly warped. Also, the vehicle is due for an oil change. So step number five, we call the parts store. We find that there are two different quality bearings in stock. I write down both prices. You document the price for the bearings. You document the price for the brake pads and the rotors. Step number six, you fill out your diagnosis sheet. You hand it to the service writer. You should show on there that the wheel bearings are the noise complaint. And we also have a recommended brake job and an oil change. Step number seven, very important one, go get a cup of coffee. So that's it. So I got another one for you. And guess what, guys, where I got all these example diagnoses from? These are real ones that have come into my shop. So, okay, we got an 02 Lincoln Town Car come on. Customer complaint, the SES, or service engine soon light, is on, and the engine shakes while driving. Okay, so step number one, we drive the vehicle and we do feel a distinct engine misfire while driving it. Step number two, we scan for codes. We get a P0302, which is a cylinder 4 misfire detected. We do a cylinder balance test to check everything, all the other cylinders, and it shows that only the cylinder number 4 is problematic. Okay, so we're on our test drive. I cleared the codes, drove it back to the shop. The misfire is still there, but the code is not reset. Doesn't mean it won't, it probably just hasn't reset yet. Step number 3, we're going to take a look at that spark plug. So I pull the number 4 spark plug out to inspect it. Find that the vehicle has 130,000 miles on it, but the plug looks pretty good. So I know it's already had an engine tune-up. Step number 4, you give the vehicle a quick inspection. It checks out. Everything looks good. It really doesn't need anything else. Step number 5, so I call the parts store and I get a price on a spark plug and an ignition coil. Parts are cheap, so I said, you know what, just get them coming. Because who's going to say no to a coil and a spark plug? You know. Step number 6, give the service writer the information. I put an hour of labor on there to diagnose and repair. You wait for him to give you the okay and you fix it. Okay, example number 3. Customer comes in with a 2006 Nissan Murano. Customer complaint. There's a vibration and he has already been quoted a rear drive shaft at the dealer, but he has a funny feeling he wants a second opinion. By the way, this one really happened. Okay, so step number 1, drive the vehicle. It runs and drives great. No issues felt. I drove it around, feels great. Step number 2, there's no codes in it. So back up a minute. So step number 1, so I did not duplicate the customer's complaint. I did not feel any problems. Okay, no codes. Step number 3, hoist the vehicle. I find nothing wrong. I look at the drive shaft, nothing. I have somebody run it up. Everything seems fine. Step number 4, during my quick inspection, I noticed that the rear passenger brake pads are dragging. You can barely spin the tire by hand. So one of the things I do in my inspections while I inspect the brakes are just quick grab the tires and spin them by hand. I did that and I noticed that the rear passenger is stuck. I can barely spin it by hand. Okay, back to step number 1. I went and drove the vehicle again because now I have a suspicion. This time I take it for a little bit longer test drive. Guess what? After a little while of driving, I start feeling a vibration in the rear. And I notice that it's getting worse and worse the longer that I drive the vehicle. Back to step number 3. I pull the vehicle into the parking lot. I immediately check the brake rotor temperature, grab my infrared temp gun, and I find that all the brake rotors are around 110 degrees Fahrenheit except the passenger rear, which measures 500 degrees. Whoa, there's a problem. Step number 5, you price out the parts for a rear brake job and a right rear caliper. Step number 6, you tell the service writer that you had just saved the customer $900 by not replacing the drive shaft. Think that's going to be a happy customer? You bet. Another funny part of that is if you would have said go ahead to the dealer, guess what? They would have put a drive shaft on it, gave the customer the vehicle back. He would have went down the road on his way home, felt that same vibration, and would have got extremely angry. So we just saved him not only money, but a lot of aggravation. Okay, one more for you guys, and then we'll be done, I promise. A 2011 Chevy Cruze 1.4 liter turbocharged. Okay, the customer complaint, the SES light is on and the vehicle just seems lazy, seems a bit underpowered. Okay, so step number 1, drove the vehicle. You verify that the engine is not running great. Power is kind of sporadic, kind of comes and goes. Step number 2, we pull a code P0171, fuel system 2 lean. We also pull P0106, map sensor performance, and P1101, intake air system performance. At this point, I don't really know. Step number 3, I research the codes and I find a ton of fixes for valve cover replacement. You also find a TSB, which is a technical service bulletin that GM has issued for an updated valve cover replacement. You watch data and you find that the fuel trims are positive 18 to positive 20% at idle. So way too high. Step 4, you give the intake a visual inspection. Everything looks good and there are no other vacuum leaks that can be found. So step number 5, I give the vehicle a full inspection or a quick inspection. I find that it's due for an oil change, but everything else looks good. So step number 6, I call the dealership, get a part number and a price for the new valve cover. Step number 7, I give the service writer the information with the parts and labor, and he calls the customer and sells the job. Okay, there it is. That was easy. We just took one of the most difficult tasks in the shop and we made it easy. So get ready, guys, because next we have Module 11. We're going to go over some of the special tools and shop equipment and just kind of get you guys familiar with the different equipment in the shop, special tools that you'll run into, and get you familiar with that a little bit. So good work, and we will talk to you next time. See ya.